Welcome to the project video of DBL Group 25. My name is Lotte Teunissen and I'm going to explain our project. All email traffic of Enron, a former energy service company, was made publicly available during the legal investigation of the biggest American bankruptcy due to accounting fraud. The dataset is provided in a CSV file and consists of 149 employees and over 31,000 emails. The dataset contains the date the mail was sent, information about the sender and receiver, namely their ID, email address and job title, and information about the mail itself, namely the message type and a sentiment. For our project, we had to make a web-based application. The application should be able to read the input data and it should show at least 2 visualizations. The visualization should be linked via brushing and linking techniques and should contain at least 1 interaction technique.
These websites were chosen for the versatility in web design and the abundance of information on how to operate them, as none of us were familiar with web design prior to this. We then split into 2 groups, one to create the GUI of the basic, including basic elements, and one to create the home page, and one team to research and test possible visualizations. From there, the basic home page and website was created, and the framework D3 was chosen to visualize the datasets. This framework was chosen as JavaScript is easier to implement into HTML, CSS websites, and then other languages.
While creating the visualizations, several problems came up. First, we had trouble with uploading the data to the web page. We resolved this by creating a fake input button on top of the button that the user is able to see. As soon as the data was transformed into the right JSON format, it became clear that the file was too big to have moving objects on the screen. This was the case because every email was processed as a separate link, resulting in over 20,000 links. After changing the way the input data is processed, this could be reduced to approximately 2,600 unique links. For the creation of the node link and arc diagram, we used the D3 JavaScript framework. Both visualizations have a similar structure, where a circle represents an email address and a stripe represents the email sent between the addresses. The graphs enable the user to spot patterns in the email data. In the node link diagram, you can spot clusters to see what groups communicate a lot between themselves. In the arc diagram, you can see with whom the different nodes and job functions communicate a lot. You can, for instance, see a strong connection between the CEOs and the presidents.
So, now that you know how the previous versions of the website look like, let's take a look at the newest version. This is the graph visualization page. Here you can see 2 graphs. Each of the graphs are minimizable, resizable, and movable. So you can create the ultimate graph experience for yourself. If we upload the dataset, you will get 2 graphs on this page. The first one is the node link diagram, and if you hover over the node, you can see which ID it belongs to and to who this person sent emails to. For example, this person sent an email to ID 7, and you have an arc diagram, which has the same thing as before.
Visualization tool, our website offers more than 3 other visualizations to aid the user in managing the data. In the roughly 2,000 lines of JavaScript code, the JSON formatted data is grouped first on whatever the user input is. This webpage shows all the secondary visualizations next to each other. Note that the final webpage looks somewhat different, but this is for presentation purposes handier. The pictures on the left about the average sentiment and the data update automatically when the user enters a new input. For example, who sends the most emails to each other. When we exclude the neutral emails, the data also changes. The pictures can also change. The sentiment determines, for example, whether the smiley is positive, so smiling smiley, or negative. The line chart works with all user input and it shows the sentiment development over a period of time. The user can hover over specific emails to see the specific dates and a specific sentiment. Rendering the graph can take up to 3 seconds depending on which input the user uses, but when you only select one email it goes relatively fast.
Our project had limitations as we were online and meeting each other was unsafe. We still had a desire to put N1 and its employees in their rightful place. The project was a very hard feat, but as you see, our hard work has paid off. But of course, as with anything, things need updates. And as we have implemented as many interactions as we can within the time frame, there's never an end to great things like this. One feature we wish to implement in the future is sharing the graphs. Would it be via WhatsApp, Google Hangouts, Discord, anything you'd like. This would improve the workload, but also allow the student or anyone using this tool to show off their skills, our skills, to our friends and family. Now, we did struggle quite a bit, but in the end, with teamwork, we figured out all we needed to make the product work, and we are grateful for such a fun and entertaining project. Thank you very much.